Hi everyone, let's go with question 7. So where we have to use discriminant to help us decide for what values of m this equation is going to have 2 real solutions, no real solutions, or 1 double root. So I'm just going to start here with discriminant in the corner. So is equal to b to the power of 2 take away 4ac. We do know double root. So if it's going to be double root, which pretty much it looks like this. So graph is going to touch the x-axis once. So that is a double root. We do know that determinant has to be equal to 0. So looking at this equation, we can see that a is equal to 1, b is equal to 8, and c is equal to m. And we're going to use this and substitute. Discriminant is equal to a is 1, but we need b is 8. 8 to the power of 2 take away 4 times a, which is 1, times c is m. So this is equal to 64 take away 4m. And for a double root, this needs to be equal to 0. All we have to do now is just to solve it. I'm going to move negative 4m to the other side. Once moved, becomes positive. And we just need m. So in order to have m, we divide both sides by 4. 4, and it's going to give us m is equal to 16. So for value of m equal to 16, we're going to have a double root. So the graph is going to look like this one here. The next one, part B, it's going to be here, 2 distinct roots. So we're going to, 2 distinct, that's, yep, discriminant is going to be bigger than 0. Again, substitute, we already have that bit here that can be used. So 64 take away 4m needs to be bigger than 0. Now we're going to move 64 to the other side, becomes negative 64. So, and divide by negative 4. And every time when you divide by negative 4 an equality, what's going to happen is that this sign, it's going to has to change to the opposite, which is going to be m is less than 16. So to have 2 real solutions, m needs to be less than 16. So, and that's going to give us graph something like that, 2 real solutions. Now part C, imaginary roots. So we do need this. I'm just gonna go on this side. Part C. Discriminant needs to be less than 0. So imaginary roots, no real solutions, like graph hanging somewhere in the air. So, and we do have discriminant already calculated. So it's less than 0. Similar procedure. Move to the other side, becomes negative 64. Now we want to get rid of negative 4, divide both sides by negative 4. And because we're dividing by negative 4, by negative number, inequality sign has to change to go to opposite of what we have, and we're gonna end up with m bigger than 16. So in order to have imaginary solutions or no real solutions, m has to be bigger than 16. Beautiful. So that would be, let's move from here. That would be, which one? Question 7. So let's now move to question 8. Move all these away. So yeah, question 8. Find the equation for the quadratic function f of x, which has the graph, and I can't see the graph. So I'm just going to sketch the graph quickly. So now we have graph here. So looking at this graph, so we do know that parabola can be written in different forms, or quadratic equation can be written in different forms. Just looking at this one here, we can see that we only have horizontal translation, so which is the graph has been moved from here along this way. So but we don't have vertical one. So vertical one is not here, so graph hasn't been moved up or down. So I can erase that as well. So, and by knowing that, so, and also that graph is touching x-axis once, we do know that the form we are gonna use is x take away h to the power of 2. So we may include plus k here, but this k is pretty much for the vertical translation, which we don't have. So and I can just erase that bit. So now we're looking what has been given, and also we do have a number here that we can call a, because we don't know that number. So that number in front of this equation is actually having effect on the shape of the graph, if it's going to be concave or if it's going to be convex. So it's going to be concave, convex, or concave. So looking at this graph, we know it's going to be convex, so which means a is going to be positive, but we don't know the value. So, and this a is also affecting, you know, how narrow or wide the graph is going to be. So what we can see from the graph, the x-intercept, or when the graph is touching x-axis, is when x is equal to 2, and we're going to substitute that. So it's y equal to a is equal to x take away 2, so to the power of 2. So now let's find the value of a. So we're looking at the graph, if anything else has been given, do we have more informations? And we can see that y-intercept has been given. So y-intercept is equal to 8. And we do know when we have a y-intercept that x is equal to 0, which means x equal to 0 can be used, and we can substitute into our equation. So y is 8 equal to, we don't know a, x is 0, take away 2 to the power of 2, 8 is equal a negative 2 to the power of 2, is going to give us positive 4, it's going to be 4a, and we just need a by itself. Divide both sides by 4, so like this, and it's going to give us a is equal to 2. Don't forget to rewrite the equation. So I'm just going to go like this, just here, and I'm going to have y equal to 2, x take away 2 to the power of 2. Voila, done. Beautiful. Bye.